In this video, we're going to look at how to apply L'Hopital's rule. L'Hopital's rule involves a limit of two functions over another in such a way that we get either a 0 over 0 or an infinity over infinity type form. If we get either of these two forms, we can use L'Hopital's rule. For instance, in this problem, as x goes to 0, x squared becomes 0, and e to the x minus 1 both become 0. This becomes a 0 over 0 form. 0 over 0 is not meaningful, so we can apply L'Hopital's rule to evaluate this limit. When we use L'Hopital's rule, we take the derivative of the numerator and the denominator separately. We are not using the quotient rule, as we would normally expect to. So in this case, we take the derivative of x squared, which is 2x, the derivative of e to the x minus 1, which is e to the x, and now we have a form we can evaluate. We have, as x goes to 0, 2x becomes 0, e to the x becomes 1. Hence, the correct value of the limit is 0. Another similar example is given by e to the x minus 1 over x squared minus 1. If we evaluate this, the derivative of the top is e to the x minus 1 over the derivative of the bottom, which is 2x. If we evaluate this one, unfortunately, does not allow us to work because it gives us a e to the 0. Oh wait, nope, it does. It does work because in this case we're going to x equals 1, not x equals 0. So we do pay attention to what it's going to. The limits, what x is going to will of course remain the same. So x goes to 1, as x goes to 1, x minus 1 becomes 0, since e to the 0. 2x becomes 2. We get 1/2 is our correct answer. The limit becomes 1/2. In this problem, as x goes towards infinity, we get an infinity over infinity form. As x goes toward infinity, e to the x becomes infinite, x squared becomes infinite. If we take the derivative, e to the x becomes e to the x, as we expect. X squared becomes 2x, once again. If we evaluate this, we get infinity over infinity. Well, it's simpler than we had before. Now we can now apply the rule again. We can apply L'Hopital's rule as many times successfully in succession as we need to. If we take the derivative again, we get e to the x over 2. In this case, we have infinity over 2 as x goes toward infinity, and the answer for our limit is simply infinity. As x goes to infinite, the value could become many different things. In this case, it happens to be infinity. But just because it goes to 0 does not mean, just because it goes to infinity does not mean our limit is infinity. It just happens to be in this case. In this problem, as x goes to 0, we get a 0 over 0 form. If we take the derivative, we get the derivative of a cosine is a negative sign, so derivative of a negative cosine is a positive. sine x over 2x. In this case, the derivative of sine x is 0. Derivative of 2x as x goes to 0 is 0. So we have a 0 over 0 form now. If we apply the derivative again, we get cosine x over 2. As x goes to 0, cosine x becomes 1. Hence, our limit is 1/2. One more problem, let's apply this to. And we'll need to use the chain rule in evaluating this. If we take the derivative of the top and bottom, well, first of all, if we take the limit, notice we have an infinity over infinity form. So, we will take the derivative and get 2, let's see, ln 3x times the a derivative of the inside becomes 1 over 3x. It's 3 over 1, which is simply the same as 2 ln 3x over x, which is very similar to what we had before. If we, once again, we look at this, we have an infinity over infinity form. If we apply the rule again, we get, so the derivative of this will be 2 1 over 3x times 3 over derivative of x is 1, which we can simplify this all down to 2 over x. As x goes towards infinity, the limit becomes 0. That's our correct answer. L'Hopital's rule is a powerful tool in evaluating limits, and it's, in some ways it's too bad we have to learn derivatives first in order to evaluate these limits, because this is such a very useful tool in whenever you're dealing with limits. This is one of the most useful tools for limits.